You're listening to the Common Descent Podcast.
Hello, David.
Hello, Will.
And hello, listeners. Welcome to episode 166 of the Common Descent Podcast. Today's episode, we are talking about monotremes.
The weirdest mammals.
Yes, monotremes are the unique group of mammals today, which include the platypus and echidnas, that are our only remaining egg-laying mammals.
Yeah.
These are super famous for that fact, but are also bizarre in a number of other different ways compared to most mammals around today. So we will be investigating this iconic and eclectic group of mammals and discuss what their history looks like, of course, but also what makes a monotreme, and are they actually as weird as they seem to be today?
Yes, and what's behind all that weirdness,
Yes.
potentially.
So we'll be discussing that. This is a super cool group of animals, so I'm excited to talk about them. And I am not alone!
Sure aren't.
All of our episode topics are requested, and this topic was very, very requested. We had requests for monotremes or platypuses from Zabby, Grady, Logan, Anna, Jonathan, Lucas, Stacia, Sebastian, Mike, Greg, Serpentine, David, Joffrey, Kyle, Jake, Risden the Raptor, Uju, Jesse, Luke, Hadley, Milu, Gavi, Belladonna, Firefly Blue, and Lydia.
And that's all the time we have for our podcast today.
Whew.
Thanks, everybody, for requesting. That's awesome.
I have to go catch my breath.
It is great to get to do an episode topic that has been requested so very much.
Absolutely. None of those, though, were for echidnas, which, where are you, echidna? What's no knuckle fans out there?
You're going to get echidnas anyway. That's what's going to happen this episode.
So we will jump into that topic after some brief announcements and our news section. So for our quick announcement section, first and foremost, we have a Patreon.
Yeah, we do.
Our Patreon supports the podcast top to bottom through the generous support of our patrons. When you sign up to our Patreon, you can get lots of extra goodies, extra audio, extra content, extra time with us through chats and so forth. And at certain levels, you can get your name shouted out here on the podcast. So we would like to welcome our newest patrons, Mark, Big House, Samuel, James, and Peter. We weren't done saying names yet.
No, this is a lot of names. There's a lot of names. Thank you to our patrons for joining us and supporting us on Patreon. We greatly appreciate it. And hey, if you're out there and you're not a patron, think about it.
Absolutely. You can support us on Patreon. You can also look down in the description of this episode for links to many other ways to support us. We have our social media. We have our Discord. You can go to the merch store and buy some merch from us. You can click on the Audible link down there,
Yeah,
which will
part
get
of the
you
Audible Affiliates program.
Yes, indeed. You'll get a month of Audible and support us, so you can get some audiobooks if you're interested. And speaking of extra content and extra bonus stuff, we are now right on the cusp of Croc and Snake Month.
We sure are. During the summer, we here at the podcast like to celebrate Croc and Snake Month. It's a grand tradition going back to last year.
Mm-hmm.
Such a big hit, we decided to do it again. June is Croc Month here for Common Descent. July is Snake Month. And just like last year, we are going to be sprinkling across these 2 months with special bonus stuff, extra things to celebrate crocs and snakes. Here on the podcast, we will have extra croc and snake content. This includes, we're going to try to find croc and snake news to talk about. We're also going to have bonus episodes like we did last year. This year, we're going to take those bonus episodes as opportunities to talk about our histories and experiences with crocs and snakes. Should be pretty fun. Those come out on Croc Day and Snake Day, which is why we do this in the summer.
Mm-hmm.
We will also be doing themed episodes. Last year, we did episodes on phytosaurs, which are kind of like crocs, and monitor lizards, which are close to snakes, episodes 142 and 143. This year, we will be doing the same idea again with themed episodes, except this time, during June and July, we will be having, for the first time in 6.5 years, another croc and another snake episode.
Yes, indeed.
We are returning to our favorite groups of animals for dedicated episodes. Stay tuned to see what the details of that are going to be. On top of that, you can follow us on social media during these months for more stuff. We're also going to have themed things on Discord. Our monthly Q&As will be themed. And we're going to reopen the June and July exclusive Croc Chat and Snake Stuff channels so that everybody can talk and share pictures and whatever you want to do. Fill those channels with Croc and Snake stuff. And on top of all that, most importantly, we will be bringing back the exclusive June and July only Crocs and Snakes level on Patreon. This is only going to be available during Croc and Snake Month. Patrons who subscribe at the Croc and Snake level will not only get some cool stuff, we've got some cool Croc and Snake Month stickers that they will receive exclusive to that level, but also the patronage we receive at that level during these months will contribute to charitable donations we will be making at the end of the summer towards Croc and Snake research and conservation. So, if you're already on Patreon, keep an eye out and consider upgrading or including that level. If you're not on Patreon, now is a fantastic time to think about joining because you can not only support us, but support the work being done to understand and conserve our favorite reptiles.
Yeah, it's going to be a lot of fun next couple of months.
We are going to be having a lot of fun. Huge thanks to everybody who's tuning in. A huge thanks to everybody who made it so much fun last year, because if it was a dud last year, we wouldn't be doing it this year. We're very excited to be celebrating Crocs and Snakes. Stay tuned for all that stuff and more details to come.
Absolutely. And in fact, we have some early Croc Snake Month content for us because we have a mailbox that you can send us mail through if you would like.
We sure do. That's also in the episode description.
And we got some mail recently. We got a Croc and Snake Month package from Elizabeth.
A little care package.
Yeah. We have a croc pin and a snake pin. The snake pin's wood carved, which is cool.
Yeah, it is. This is very cool.
We also have gator and snake notebooks or journals. The gator one is all holographic, or where it makes it look 3D.
Yeah, this one appears to be covered in North American snake species.
Oh, that is what it is, isn't it? Yeah, and they're cool, like old nature book drawings.
Yeah,
which I love.
That might be a mamba, so I might be wrong about the theme. But there's a bunch of cool snakes on here.
North Americans, native and zoo snakes.
Yes, absolutely.
That's what you meant. So thank you so much, Elizabeth.
Thanks, that's great.
And with that, we can wrap up our announcements and move on to the first official section of the podcast, the news. Every episode, we like to collect some recent bits of science news, paleontology, biology, evolution, and share them all with you so that we can stay up to date with current research and what's going on. What's the news, David?
I've got two newses. The first one is about mosasaurs. Specifically, a new mosasaur that was weird. This is research by Nicholas Longrich et al. In the journal Fossils. And in the blog post, link in the description, we will include a link to a press release from the University of Bath in Newswise. Mosasaurs, as we have discussed before, episode 51 and also a bunch of other times, are the aquatic lizards from the late Cretaceous period. Super common, super diverse across oceans of the world. In fact, it has been noted that mosasaurs achieved really notable diversity in forms and in lifestyles in their relatively short time that they were all over the oceans.
Yeah.
This study identifies a new mosasaur, a new genus and species of mosasaur. This mosasaur is Stellidens mysteriosus. This mosasaur comes from the Maastrichtian of Morocco, so the very latest Cretaceous. The phosphate mines of Morocco, as it turns out, include the world's most diverse mosasaur assemblages. So it's not a surprise to find something new in this area.
Cool.
This mosasaur is only known from a partial jaw and 2 teeth, which isn't much, but it is enough to talk about 2 main things. One, the size and dimensions of the jaw suggest that this was probably about a 5-meter long mosasaur, or 16 feet, which is a decent size for a mosasaur. But the real attention getter has been the teeth. This mosasaur has teeth that are not only unlike any other mosasaur, but unlike any animal that has ever been seen. Typical mosasaur teeth are cone-shaped with a ridge on the front and a ridge on the back that have serrations on them. Those serrated ridges make the tooth act like a blade, and it helps cut through meat and stuff. That's not at all uncommon. We see similar serrated ridges on a bunch of dinosaurs. You see them in crocodilians. You see these in certain lizards. These serrated ridges are called carinae. And again, most mosasaurs have one in the front, one in the back. Stelladen's 2 teeth that are found in this fossil have a whole bunch of extra ridges. On the inside surface of the tooth, the part that would have faced in addition to the one on the front and the one on the back, these 2 teeth have between 4 and 6 extra ridges.
Wow.
Along the surface of the tooth. The name Stelladens means star tooth. Because these ridges give it... The article describes it as looking like a crosshead screwdriver. It's got all these ridges pointing in different directions. And the species name, Mysteriosus, hints at the fact that we don't know what that is about.
Yeah.
Like, what are those ridges for? Now, a very common question that comes up, fans have asked us this question a lot, and I've gotten this question in like museum programs. When you find a weird thing in the fossil record, how do you know it's not just a strange, deformed fossil? And they actually address that in the paper. They note that extra ridges on teeth have been noted as growth abnormalities in dinosaur teeth and other animals. In this case, they said the fact that they have 2 teeth with the same pattern of ridges on them, and the fact that the teeth even would suggest that this isn't just a fluke that happened randomly to one tooth. And also, they said in the paper something to the effect of, if this was a developmental abnormality, the tooth should look like another mosasaur.
Yes.
And they're weird. They are very distinctive looking teeth. These appear to be the shape this mosasaur's teeth were. Which raises the question of, what were you doing with these teeth? Nothing else has this kind of structure on their teeth. And there's a whole discussion in here about trying to decide if they had a particular diet. They point out that prominent ridges are common in animals that eat aquatic food like fish and squids. You see big ridges in crocs and ichthyosaurs and spinosaurs. But those teeth tend to be tall and slender, and these are short and stout. Short and stout teeth tend to be stronger and therefore may be good for crunching on hard stuff. But we have mosasaurs with teeth adapted for crunching mollusks and hard-shelled things, and they tend to be rock-shaped. They tend to be blunt.
Like a mortar and pestle for crushing.
Yeah, and they tend to have really thick enamel on the teeth, which they don't see here. The authors point out that it could be that the extra ridges were good for fracturing thin shells, things like shrimp or ammonites, but there are other animals thought to eat those kinds of prey that don't have ridges like this. So it's very hard to say for sure what this weird screwdriver-shaped tooth was supposed to be doing.
Yeah, that was the first thought I had, is that maybe this is for a rock hammer of, I've got a stout but strong point for cracking. Well, more like the safety hammers that you can get for your car to break the window.
Oh, sure,
that have that little spike on the end. That's a small but stout and powerful cone. That's the first idea I had, but yet they make an excellent point that we have others thought to be adapted for eating the kind of stuff that would be good for, and they don't have similar shaped teeth.
Now, the authors point out that one possibility is that it was doing something that we just don't have a comparison for. It's possible that they were eating something weird, or eating in a weird way.
Yes.
That these teeth, they had a unique form of capturing their prey that these teeth helped them with. There was a great line in the actual paper when they were talking about its teeth could potentially be for fish or squid eating. And they said, if Stelladens was a fish or squid eater, then it seems to either have hunted unusual fish and squid or had an unusual way of catching them.
Yeah.
It seems to have been doing something with the teeth that we don't have any other animals that are doing that.
That was the other thought I had, was perhaps you are targeting your bites in a very particular way.
Yeah.
Like, maybe these are allowing you to get around the defenses in a more precise or unique way. I have no clue what that would be. I have no answers for what this unusual thing would be, but I can definitely see there being some unusual way that these teeth fit into the defense of some animal somehow, whatever their prey might be, in a uniquely effective way.
Yeah. So these teeth, this new kind of mosasaur that we don't have anything else about, seems to have likely either had a unique solution to a common problem, or has a lifestyle that doesn't exist today and that we have no other representatives of.
Yeah.
So now the next step is go find more of this mosasaur and its environment and see what else we can learn.
Well, and that's the fun and weird thing about prehistoric predator-prey relations, is you can get weird predators like this, where it's like, we don't have a predator that represents you, but you may have been hunting a prey that we also don't have a representative of today.
They described in the paper that we could very well be seeing a animal that occupied an extinct niche.
Exactly.
Like this ecosystem role, that whatever you fit in your ecosystem doesn't exist today.
Yeah, there could be some extinct fish with a type of defense or armor that really isn't represented anymore. And so these teeth only made sense back then.
Or they were using them to unscrew the ammonite shells.
Yeah, exactly.
You pop off the ammonite shells and get in,
and then you just
squishy
unroll them and you can squeeze them out. Well, my first news is also about unique toothed predators. This is a study on sabertooth cats.
Oh, which also have those carinae, those serrated ridges on the teeth.
Indeed. This is a new species that shines some light on potential major transitions in the early evolution of at least one major sabertooth lineage, but potentially others as well.
All right. So we got to get all the tooth discussion out of the way before we get to our main topic of animals without teeth.
Exactly. I couldn't go a whole episode without mentioning teeth. This research is by Chigao Zhengzhua et al. In the Proceedings of the Royal Society B. Biological Sciences. And the news article we'll be linking to is by Evrim Yazgin in the Cosmos magazine. This research described a new species of saber-toothed cat from the Tibetan plateau named Amphimacaridus hujungensis.
The Tibetan plateau, that's very cool.
Yeah. This dates to the Miocene, somewhere between 9.8 to 8.7 million years old, and is currently known the most primitive species of the Amphimacaridus lineage. So there are other of this genus known. They're found in Europe and Asia and North America. They are the most widely distributed and one of the most successful saber-toothed cat genuses in the Miocene. So during this time of the late Miocene, this was one of the groups of saber-toothed cat.
Yeah, this was one of the cats doing it right.
Mm-hmm. They are a member of the larger group, the Macaridontini, which is basal, puts them basal to Homotherium, which is the famous and often cited saber-toothed cat. This is kind of like the archetypical saber-toothed cat, which was alive around 4 million years ago up to just 12,000 years ago. And it is a decent-sized cat. It would have been around 2 meters long, so roughly lion or small tiger-sized, which still makes it smaller than Homotherium, but also a big predator. They have a nearly complete skull of this specimen, which they were able to analyze, and noted some unique features. It shows plenty of features that are typical to its genus that we expect to see, but also a couple of peculiar ones, notably a wide forehead and long snout and smaller incisors. In addition to that wide forehead, they noted the orbits, where the eyes would be, are laterally, so off to the side and a bit further back. And some of its cranial features are closer to those, or at least resemble those, of Homotherium, which potentially is suggesting a convergent adaptation to the way Homotherium was living.
Yeah.
Because this is from a basal group to one of the later saber-toothed cats.
Yeah, this is an earlier branch of the group.
We can get a look at some of the shifts between more basal saber-toothed cats and later saber-toothed cats, as well as looking at potentiality for similar lifestyles. They noted the long snout and laterally oriented orbits suggests better ability for observing the surrounding environment, giving them a better look at their surroundings.
A wider view.
Mm-hmm. At least more specialization toward that versus targeting single prey.
Right.
So this is giving a wider view versus that targeted predator view that we typically think of as the go-to predator thing to do, which suggests that this is likely an adaptation for either open environment and or social behavior.
Mm-hmm. For surveying a wide area.
Yes, exactly. Both things that have also been potentially attributed to Homotherium, which could suggest why there might be similarities.
Yeah, that this might be two different parts of the sabertooth family tree evolving similar lifestyles.
They noted that this shift in hunting behavior to potentially more open environments also coincides with an environmental shift at the time of more arid environments showing up.
Right.
Things
so you
getting
had more open environments that could be the homes for these cats with this adaptation.
When you get things drying out, that tends to reduce your forests and open up your grasslands. This likely is due to the Tibetan plateau raising up,
Mm-hmm.
and that was also happening during this time. So this was likely one of the major drivers for this quick morphological change that we see in them, and that is represented by these features, and appears potentially to be one of the major steps in saber-toothed cat evolution that may have led to their global dispersal and success. That this shift seems to maybe be linked to that phase of saber-tooth history. They noted that open environments are beneficial for social behavior. You have more visibility for your fellow, pack mates, group mates, so that you can coordinate. You also are more visible to your prey, making them more difficult to catch. So having potential help with catching prey is another driver. And they noted that a pathological forepaw in this specimen provides some potential evidence for at least partner care, that they may have been getting aid from another member, if only just a family member. So some potential support for, or at least things that could point in the direction of social behavior, but that is always a hard thing to nail down. And the analysis of trait evolutionary rates seems to show that the features that seem to correlate with this killing behavior, this hunting behavior, and open environments evolved prior to other traits that we see in later lineages, meaning that it may have been a very key and strong driver for this group that could have set up the opportunities for those later adaptations to come along.
Saber-toothed cats are such a fun group to get to talk about because we so often discuss very specific cats. Smilodon, especially here in North America, Homotherium for some of the older stuff. So it's super cool to be reminded of the diversity of saber-toothed cats in all different parts of the Tibetan Plateau is a very cool place to think that we had a different group of saber-toothed cats living slightly differently, adapted to slightly different environments, with a mixture of things that are similar to certain other cats and then their own stuff and their own evolutionary pressures and history.
Absolutely. It's often very easy to group saber-toothed cats as a type of big cat like you would tiger.
Tiger.
Exactly.
But tigers are tiger. Like that's a very specific group of cats.
Whilst as we find out more, it seems more like, just as you wouldn't say a jaguar and a lion are just two cats, or just big cats. No, those are very distinct.
Mm-hmm.
We're seeing that there was a similar level of diversity and distinctness. Speaking of big predators, they also noted that another driver could just be that there were other big predators in that area.
Mm-hmm.
The giant hyena, Dinocrocuta, was in that area, as well as at least two yet described species of bear. So competition with other predators could also have shifted their hunting behavior.
Right. If those are all doing really well in the forests, then you might move out to the plains.
Yes. So there are other explanations that don't require social behavior as a major driver.
Cool. Well, on the note of large extinct mammals, I've got a news here about growth patterns in large marsupials.
Ooh.
Ancient marsupials. Which aren't monotremes, but, they live in the same place.
Oh, they're neighbors.
This is research in the Journal of Paleontology by Anusuya Chinsami et al., and we will link in the blog post to an article by the authors of the paper in the conversation. The marsupial in question is named Nimbodon lavaracorum. This is a large marsupial, an extinct marsupial from about 15 million years ago, a Miocene, found at the Riversley World Heritage Site in Queensland, Australia. a very expected place to find marsupial fossils. Nimbodon belongs to a group called Diprotodontids, which includes some of the biggest marsupials that ever lived, also closely related to modern-day wombats. But Nimbodon is most often compared to bears. Partially because it's big. These are estimated to have weighed about 70 kilograms, or about 150 pounds. But also because, despite being very big, they have a lot of adaptations associated with climbing. They have strong arms, they have flexible joints, grasping hands, and big curved claws. The kinds of things we see in sloths and bears, things that do a lot of climbing. The article specifically compares them to sun bears.
Oh, okay.
Modern day sun bears, which spend a lot of time in trees. They do a lot of climbing around. They're not huge like grizzlies, but they're still large arboreal mammals.
Yeah, the first thought I had was black bears, which are also still very good at climbing, though they're not a tiny bear.
Right. So in that regard, they're also occasionally compared to things like koalas, which are today's famous arboreal tree-climbing marsupials. This study was not actually looking at their climbing abilities, but growth patterns, digging into the bones to understand how these animals changed over their lives. They took histologic sections, so cut very thin sections of leg bones, put them under the microscope to look at the patterns in the bone tissue. They looked at several individuals. They listed 5 femora, so femur, the thigh bone, and 5 tibiae, shin bones, from a variety of aged individuals, from young to adult. And they noted some interesting growth patterns. Overall, interestingly, slow growth patterns.
Oh.
The patterns in the bone tissue suggest relatively slow growth. They did note interrupted growth patterns. So this is something we've talked about before. You see this in dinosaurs, you see this in crocs. You see it in trees, where the tissue grows faster at some times and slower at others, and this leaves what are called lines of arrested growth. That's what tree rings are. This has been seen in some living marsupials, apparently, including certain kangaroos, that they also have these cycles of fast and slow growth. These cycles are typically affected by environmental change or changes in resources, changes potentially in the physiology, what the body is doing. So body temperature or metabolism might go up or down. It indicates that Nimbodon, this ancient marsupial, went through cycles. Presumably, it's very easy to suggest these were yearly cycles, because in a lot of organisms, it's winter to summer, winter to summer. Although the authors point out that doesn't necessarily have to be what the cycles are. In one of the specimens that was mature, they counted these rings to estimate that this animal seems to have taken at least 7 to 8 years to reach full maturity, which again is very slow compared to marsupials that have been studied. Even kangaroos are fairly big today. They've noted reach maturity in 1 to 2 years.
Yeah.
So taking several years to do it is a very slow-growing marsupial, and those patterns of the bone tissue suggest that even during their fast growth periods, they were still growing slower than other marsupials. So overall, this points a picture at these ancient... They called them the real-life version of drop bears.
Yeah.
of Australia's mythical drop bears. These ancient animals had very slow growth and development compared even to other modern marsupials.
Interesting. I wonder what the utility might have been for them. The first thought that popped in my head with comparing them potentially, or just mentioning koalas, who famously eat eucalyptus, which is famously not a good food source, and often have very... At least, I don't know how their growth, pertains to other marsupials, but that they have very low energy lives, very slow, very, energy efficient, and it's because they do not have the excess energy from their food to just go scampering around the trees like a squirrel.
It's really interesting that you mentioned that, because my last note on this study talks about bone remodeling. So in the bone tissue, you can see... The bone doesn't just grow and stay that way. Yeah. Even the earlier parts of the bone are changing over the life of the animal. And they noted that there's a lot of evidence of relatively extensive remodeling of the bone, which we don't see in koalas. They specifically compared this to koalas because they said that remodeling can be encouraged by the stress of moving around.
Okay, yeah.
Locomotion, just moving around your environment, can create stress on the bones that leads to that remodeling. And the fact that these animals have a lot of it and koalas don't might mean that they were actively moving around the environment more often. They may have been, despite being very slow to develop and slow growing, they may have been more mobile around their environment, which is another thing they would have in common with bears.
Yes.
Like bears often tend to cover lots of area looking for food. Koalas are also very small.
Yeah.
They can get away with not moving around a ton to find a lot of food.
Oh, yeah, no, they can stay in that tree for quite some time.
Yes.
It'll take you a while before you run out of eucalyptus.
Like tree sloths. Like, yeah, you don't need to go anywhere fast. You've got all the things you need.
Very interesting. Yeah, I'd be very curious to see future studies that and what it might indicate about what lifestyle would fit this sized animal and this kind of growth.
Yeah. It's a very cool time in paleontology where we can look into the bones to get information beyond just shape of teeth, shape of skull, to how were you developing and growing, and what was your skeleton doing over the course of your life. Very cool insights.
Excellent.
All right, beat that.
My last bit of news does not have anything to do with that news, but it does have stuff to do with your first bit of news because it is also about a marine reptile.
Oh, we should have rearranged. Yeah. We should have talked about this ahead of time.
So I wanted to end cap, you know?
Oh yeah, that's great. Marine reptiles on all sides. I'm here for it.
What's better than a marine reptile sandwich? This is research on what seems to be a very, very big pliosaur.
Ooh.
Yeah, which are the typically short-necked cousins of the long-necked plesiosaurs.
Yeah.
This research is by David Martell, Megan Jacobs, and Roy Smith in the Proceedings of the Geologist Association. And the article we'll be linking to is by Kavita Verma in Interesting Engineering. This research is on just 4 backbones, 4 isolated vertebrae. They said specifically cervical vertebrae.
So neck bones.
They discovered these in the Abingdon County Hall Museum in Oxfordshire, England, whilst photographing a different skeleton of an ichthyosaur. So they weren't looking for these, they were photographing something else and noticed these in the collection. The info with the vertebrae had that they were from the Kimmeridge Clay Formation, which is an upper Jurassic, so around 152 million year old fossil formation, and identified them as pliosaur. And so to paint a bit more of a picture, these are 4-flippered like plesiosaurs and are in the same group as plesiosaurs.
Yeah, technically they are plesiosaurs,
yes.
But they're not the plesiosaurs.
Yeah. When you think of plesiosaurs with a long neck like Elasmosaurus and stuff like that, these are a group, and the shape is often called pliosaur, where they have a shorter neck and a much bigger croc-shaped head.
Yeah, this is the group that includes Liopleurodon and Kronosaurus, I believe, is in there.
Indeed.
More details in episode 72.
Yes. Immediately noteworthy of these backbones was their size and their shape. They were very short relative to their width and height. They give dimensions. Their maximum length was 10.3 centimeters, roughly 4 inches, with a maximum width of 26.9 centimeters, 10.6 inches, and a maximum height of 22.2 centimeters, or 8.7 inches.
That's a big neck bone.
Yes. So it is not very long, wide and tall. They also noted tall rib facets on the center part of these vertebrae, so where the ribs would attach.
For neck ribs.
Mm-hmm. They were notably tall, it sounded like. They performed some scans, topographic scans, so that they could compare them with other pliosaur vertebrae. These included some mid-Jurassic, so similar aged pliosaurs, including Peloneustes and Liopleurodon, and some early Cretaceous pliosaurs, Stenorhynchosaurus and Sanchiosaurus. With some just simple scaling, they didn't make it sound like this was definite, but based off of those comparisons, simple scaling of these verts gives a body length of between 9.8 and 14.4 meters, or 32 to 47 feet long. And they said that, in their opinions, likely toward the higher end of that range than the lower end.
Interesting.
Now, this is likely a new species, but they could not determine what genus and species it should be in, so they did not provide a name. They said very potentially genus could be Pliosaurus or a similar group. They do not know what the neck length would have been, so they don't know how Pliosaurus shaped or elasmos, they don't know exactly what length of neck we might be looking at. One of the things the article mentioned that makes this notable is that it potentially gives some reason to look back on size estimates given for Leopleurodon famously in Walking with Dinosaurs.
Yes. One of the reasons Leopleurodon became famous is it was featured in Walking with Dinosaurs, but they also gave a size estimate that was like twice the size that more accurate estimates have come to.
It was 25 meters long is what it was cited as.
Which is very, very big.
That is huge. And lots of people responded saying, eh. And it was based on research at the time that used fragmented data to calculate that size. But they noted that these ribs, these verts, though not that big still, are bigger than we've found pliosaurs typically.
So we may be pushing the upper size limits that we know of a little bit.
Yeah, that size may not be quite as ridiculous as it initially seemed at the time.
It's slightly closer to reality.
Yes. So this could spark also re-examining other size estimates for other pliosaurs now that we have just a potential upper range of examples to add into the data.
Sometimes all it takes is a handful of bones to indicate the presence of an animal in a fossil locality that was just different or doing something different than others that can get us starting to think about the diversity of that group.
Absolutely. And with that, we can wrap up the news, meaning that we can move into discussing even weirder organisms than giant pliosaurs.
I think weirder than all the things we talked about. Early, weird saber-toothed cats, and star-toothed mosasaurs and giant pliosaurs, and even big drop bear ancient marsupials. I would absolutely go ahead and say that monotremes are weirder than that.
None of these can sting you. We're going to talk about monotremes and go through what is a monotreme, what are the monotremes today, and what makes them so unique. So monotremes, the famously weird group found in New Guinea and Australia today, are famous for a number of things, mainly being the only remaining egg-laying mammals around.
Right. They're the mammals that are seemingly doing a bad job being mammals.
Yes. That is what they are famous for, as being notably distinct from the rest of mammals that we know, and are studied for that in many, many ways. So first, monotremes or monotremata will also sometimes be called prototherians, which is a kind of nowadays outdated term. This is in relation to the eutheria, which is our placental mammals, metatheria, the marsupials, and then prototheria, the monotremes.
Right. Theria, it often is used kind of to mean mammals in general.
Yep.
Prototheria would mean before mammals, which is not really quite accurate, but you can see where they're coming from.
I saw it described one time as a outdated teleological definition of goal-oriented. It puts eutherians, our group of mammals, at the pinnacle of mammal evolution.
Which is a term that loosely means true mammals.
Yep, exactly. So you'll hear that term used, you'll see it come up in studies sometimes, it still floats around, but monotremata is the actual group name, the crown group for today's monotremes, their extinct relatives, and the common ancestor that they all evolved from. Classification-wise, you will still see, as I said, them classified under prototheria, which also includes things like triconodonts and multituberculates and other close to mammals or early mammals groups. But you'll often see them under a group called Australosphinida, which is a Jurassic Cretaceous Gondwana, so southern continents group. This is also debated, and we'll talk about that more when we talk about their fossil and evolutionary history. In fact, when you go to that Wikipedia page, it has a question mark next to monotreme under what groups are included in this group. So, like, it is still very much some people lean that way and will still use that grouping, others don't. So monotreme is kind of floating around the taxonomy a little bit. There's not a full agreement on how we should designate them in relation to other mammals. But basically, monotremes today make up a group isolated to New Guinea and Australia, which includes your platypus and the echidnas.
And the end.
That's it. That is the entirety of modern monotremes. And those are your two families.
And like you were saying, what makes monotremes so interesting phylogenetically is that they're not just a group of mammals. They are distinct from all the rest. They're not marsupials, they're not placentals, and that's all of other mammals.
Exactly. So they are doing something...
They're the third group of mammals.
Yes, they're doing something unique compared to those groups.
They're sort of the tuataras of mammals.
Yeah, no, that's a really good way to compare it.
They're outside the rest of lepidosaurs or squamates. They're their own sort of weird thing that's not a lizard. These are not like other mammals. Also, same basic part of the world.
Yes.
Isolated to some land masses that are not in contact with other places.
And in a similar way, they will often get viewed in the same kind of light that the tuatara will be as a relic of a bygone era, primitive compared, and living fossil that is somehow still here.
Stuck the way that this lineage was back in the pick your ancient time period.
Exactly. Monotremes will get treated in a very similar way, which is a definite disservice to the unique features that they have shown that are not just ancestral, old, early mammal features, but are unique monotreme features.
Yes, they're not just old weird mammals, they are modern weird mammals.
Yes. The two families found in monotremes today is the Ornithorhynchidae, which is the platypus, and the Tachyglossidae, which are your echidnas. Within platypus, there is the platypus.
One
There's
species.
only one species, Ornithorhynchus anatinus. This is also the smallest extant monotreme today.
Oh, yeah.
They are the smallest. They tend to only weigh about 0.7 to 2.4 kilograms, or 1.5 to almost 5 pounds, or to just over 5 pounds. And they are semi-aquatic. Typically, you're going to find them around streams, rivers, and lakes in eastern Australia and Tasmania, excluding northern Queensland. So they have a fairly narrow range. They're not widespread. And they'll be hunting all sorts of invertebrates in those water habitats. Whilst echidnas have 4 modern species. You have Tachyglossus aculeatus, which is the short-beaked echidna, and then the long-beaked echidnas, which is genus Zyglosus, and has 3 species. These two groups of echidnas have very different distributions. Your long-beaked echidnas are isolated to New Guinea. That is the only place they are found. They're typically a little bit larger and less spined, because that's one of the things with echidnas. They are covered in keratin spines, very much like a hedgehog, kind of like a porcupine.
Sure. And they live on their island and they guard the Chaos Emeralds.
Yep. These would be the ones most similar to how Knuckles is compared. Because the short-beaked echidna is the most widely distributed mammal in Australia, including marsupials and placentals that have been introduced to Australia.
Huh.
They are one of the most successful mammals on Australia.
Wow.
And definitely the most successful monotreme today.
Fascinating.
Yes. So the short-beaked is just doing it.
Doing great.
They are awesome. They are both insect eaters. They have strong claws for digging, and typically are going after termites and ants and stuff, as well as worms and soft-bodied invertebrates. And that is the entirety of modern monotremes. That's all there is left today. They are isolated to that area of the world and have numerous features setting them apart from other mammals. They still have the mammalian minimal features, the minimal requirement of fur, and they produce milk.
And they've got a bunch of those skeletal features and skull features and all the classic mammal stuff.
But they do have some distinct features that are unique to monotremes, at least among mammals.
Right. And it's a combo of things that are unique to them because they're weird, like platypuses, where that platypus shape with your duck-like bill and your beaver-like tail and your whole deal is very weird because platypuses are weird. But also the things where they're missing features or have odd different features that set them apart from all other mammals.
Exactly. That duck bill that the platypus is so famous for, a bill or beak is a monotreme thing. Because the echidnas also have a very beak-like snout, that their mouth is toothless and long and narrow and doesn't open much. Very anteater-esque, but often referred to as a beak as well. These beaks are also not just beak-shaped. They are unique in that they are typically covered in sensory cells for high sensitivity to touch and often electroreception.
Right. They're sticking their faces into the dirt or the mud at the bottom of a stream or whatever and feeling and sensing what might be moving around in there. Very similar to things like bottom-dwelling fish and stuff like that.
And electroreception is famous in platypuses. Electroreception being the same sense that sharks and rays have to sense the electrical fields around other organisms. Theirs are very similar to the ampullae of Lorenzini found in sharks, but slightly different. They don't actually have sensory cells, but naked-end nerves in the pores to detect the electricity. And they are found in echidnas. Echidnas are electroreceptive, making them one of the only terrestrial electroreceptive animals, period.
Interesting.
That is not a thing you typically find in animals outside of the water. They are less electroreceptive than platypuses. They have far fewer of the sensory pores and much higher focus on mechanoreception, or touch and feel, to their snout, as well as a much stronger sense of smell compared to the platypus. But they are still electroreceptive, so that is a monotreme trait.
Interesting.
They also famously lay eggs.
They sure do.
Kind of their thing. They are the only surviving egg-laying mammals today. Their eggs are leathery skinned, so they're not hard-shelled like a chicken's, but a little bit more pliable. They do produce them from a cloaca, which is also unusual for many of us.
Yes. Mammals typically don't have that.
That is something they share with marsupials. Marsupials also have cloacas, so that is not a monotreme thing. It just is a typically unfamiliar to us placentals.
And these are all things that are thought to be the old thing for mammals.
Yes.
That ancestrally, mammals laid eggs, and mammal ancestors laid eggs. Ancestrally, mammals had cloaca, just like reptiles do. A single exit for all of the other end-of-the-body exits. Placental mammals have moved away from those traits and then became the mammals that took over the world. So now those traits seem normal. Monotremes have held on to egg-laying, and monotremes and marsupials never lost the cloaca. These are, I don't want to call them relics, but they are traits that they share with the ancestors. They didn't move away from them.
Exactly. Echidnas and platypuses also handle their eggs slightly differently. A platypus will nest. They are burrowers. Both are accomplished diggers, and platypus will make burrows on the sides of riverbanks. Echidnas can burrow wherever they want, and platypus has to leave its egg and young in the burrow. Echidnas actually have a pseudo pouch. They have a fold in their abdomen where they can carry the egg with them while they forage.
Interesting.
Yeah. So the mother echidnas can actually take their egg and newborn young, which in monotremes are called puggles.
Yep.
So they can carry...
Fun fact for the episode, puggles, enjoy that.
Yep. They can carry their little newborn puggle with them until they start gaining quills, and then they'll take them to the burrow, where that's where they will stay.
Right, now you have to not be in this little pouch because, ouch.
Ow.
Yes, exactly. I think you're old enough now to leave the pouch.
Yep.
That's fascinating, the idea of the marsupial-like pouch, but with an egg in it.
Yeah.
Like Chansey.
Exactly.
I'm just carrying my egg around in the pouch.
And that's a very there's not a lot of animals that carry their eggs. They're
already
laid
hatched.
egg.
Yeah,
Yes.
already laid eggs. Yep.
Like penguin is the first one I can think of.
Sure.
That carries it on their feet. So very unusual. And though this is now a famous thing about them, it actually took, European researchers quite a long time to accept that this was a thing monotremes did.
That they lay eggs.
Yes. Even though the Aboriginals had already told them
Oh, sure.
that they lay eggs.
This animal is found all over this area. They lay eggs.
It took decades after the first specimens were brought back to Europe for it actually to be accepted by the scientific community that they laid eggs. And it went back and forth with some saying, well, maybe they lay eggs, but they don't produce milk, so they've got to be something weird. Or others being like, well, they probably produce milk, but they don't lay eggs.
Right.
Even Richard Owen was vehement on them not possibly laying eggs for quite some time, which probably was part of the delaying aspect for such a famous researcher to be in that camp.
Well, and it's funny because monotremes are one of the go-to examples for when we, for whatever reason we've chosen, want to break down the way we teach animal groups in schools. Like, still to this day in school, we learn mammal, reptile, bird, amphibian, fish, and mammals give live birth, have fur, produce milk, all the mammal stuff. Monotremes break the trend. Monotremes are the egg-laying mammals. Because nature doesn't fit into boxes, these animals are all part of the same brand family tree. The lines are blurry. But that system of, we have classified these with these hard lines, goes back quite a ways.
Absolutely.
And so someone coming up and telling the premier researchers in the Western world, we found mammals that lay eggs. Yeah, it's not surprising that they were like, no, you didn't, because we made these rules.
Yeah, no, have you not read this book?
You didn't read my book. Here's my book. Mammals don't lay eggs.
Yeah, exactly. And some of you may be wondering, okay, but why were they confused about the milk? They do produce milk. Monotremes do indeed produce milk, but they do not have nipples.
Right.
Which is why if you were just given a dead platypus, you'd be like...
Right. There are no teats here for the milk to come out.
You silly. Where would the milk even come from?
What's it doing? Sweating milk?
Yeah, that's what they're doing.
They are sweating milk.
They have milk patches. The females have milk patches that are typically like 2 oval sections on the abdomen, on the underside, that are very, very similar to sweat glands. The mammary glands are associated with a mammary hair, and sweat milk, very, very similar to the way our sweat glands produce sweat in oil.
Once again, potentially an ancestral a modern version of this ancestral style before true nipples evolved, an actual delivery mechanism for the milk, producing milk and letting it out through the skin to be available for a young growing mammal.
Yes, and it is thought that mammary glands ancestrally were sweat glands of some sort, and that they developed into this nutritional producing role.
Right. And then later would have developed an actual organ to deliver this nutritional fluid directly into the mouth of the newborns.
Another thing that monotremes are just kind of weird for is they have ears, but nothing on the outside.
Oh, yeah, that's true.
They have no ear flaps.
Yeah, much like reptiles.
Yep.
That don't have flappy external ears like we do.
So they just have holes in the side of their head where they can hear from. From the things I read, not particularly robust hearing.
Yeah, well, they're missing the satellite dish.
Yeah,
that
exactly.
collects all the information.
And then one of the other extremely famous weird things about them, but I feel like doesn't get into the fun facts about them as often, is venom.
Yep.
That is often a thing that I feel like gets either missed or just not as talked about.
Because there's already so many other weird things. We can't handle too many on that list.
Yes. Platypuses have venomous spurs on their ankles, on the back feet, that they can, like the,
like cowboy boots?
Like when you jump and you click your heels together?
Yes.
That's what they do with those 2 spurs to be able to envenomate and use that as a venom delivery system.
Yeah. This is really interesting because there are venomous mammals. We did Venom and Poison, episode 97. There are mammals with venom, things like shrews that are venomous. But like almost all venomous tetrapods, they're delivering it with their teeth.
Yep.
To have spikes on your ankles that deliver venom is very unusual and distinctive for platypuses.
Absolutely. And echidnas. They have spurs, but not venom. Only the male platypus is venomous, but monotremes have these ankle spurs as a given. It is more prominent in the males. Female platypuses will have them when they're younger and then will lose them early in life, like within the first year. And female echidnas often will lose them as well or not have them.
Sure. But males are hanging on to them for kicking each other, presumably.
And so male echidnas and male platypuses have these spurs. The male echidnas' spurs don't have venom, but they do have potential other uses. They seem to maybe produce scent, so they might be for scent communication.
All right.
Producing a waxy substance during breeding season. In monotremes, this is known as the crural system, which is referring to the back legs. This is the name for their venom system. They have a pair of venom glands on the top of their pelvis that run down ducts to the ankles.
Weird.
Yeah. The spurs are a keratin sheath around some of the ankle bones, the calcareous core for the spur itself, and the os calcareus, which is the supporting structure for the spur.
Right. So it's kind of like that bony part of your ankle that sticks out a little bit, extended into a spike with a sheath over it, like we talked about with the claws episode.
Yeah. Yeah. This is a horny structure, very much similar to those. Some of these bones will be absent in females, so they won't have the supporting structure for the spur, even if they may have vestigial spurs. In the male platypus, they will have tendons and muscles connected to the spur, so it can be erected and go from a non-envenomation position to an envenomation position.
Wow.
And be locked.
Wow, like
So-
a viper.
Yes. So well, in fact, that they can hang from their spurs once they've latched onto someone.
Wow.
So-
probably not good for them.
No,
but still.
But also, whoa.
Yeah.
The echidnas in females don't have this musculature, so they cannot erect their spurs. So
Mhm.
theirs seems to be very much a reduced version of this curl system. Now, why they're venomous has been talked about quite a bit, because for many, venom is used in hunting, and that sure doesn't seem to be the case here.
Right. Snakes, shrews, and so on.
Like, not only is this on the wrong end of your body, but also the food platypuses eat are small invertebrates.
Yeah, you just suck those right up.
Yeah, that they would not be able to effectively envenomate with these spurs that are probably the same size as their prey.
Yes.
So it's not likely prey capture. It could be defensive, though that is not observed regularly.
Right, them kicking at predators and stuff.
They don't have a lot of natural predators nowadays. There have been instances of humans being envenomated by platypus. Though this is rare, there's not many instances this has happened. It is extremely painful.
Mm-hmm.
It is supposed to be horribly painful with a bunch of potential side effects: swelling, nausea, cold sweats, lymph node swelling, muscle wasting, and an excruciating pain that cannot be relieved by conventional painkillers, including morphine, but can be alleviated through a nerve blocker.
Wow.
So
don't get kicked by a platypus.
leave them alone. Leave them alone. There is no antivenom available, so just let them be. The most likely use for this venom is a reproductive tool for males to combat each other during breeding season.
Mm-hmm.
This is supported by the fact that the venom system is more active during breeding season. This glands swell and become more productive of venom, and the male's behavior becomes more aggressive and more likely to spur at rivals, but as just at animals in general. And fresh spur wounds have been noted on males during breeding season that seem to heal, so it doesn't seem to be fatal.
Mhm.
But spurred males have been noted to be temporarily paralyzed, which could just be enough to deter them taking territory or keep them from breeding.
Yeah.
Just take you out of the game for a little
Just
bit.
change their mind.
Yeah.
Don't come back. Don't mess with
Mhm.
me.
And that it could just be a tool for males to fight one another. It could also have a breeding purpose in echidnas. Noted that, once again, their ducts seem to be more active during breeding season, but it's not producing venom, it's producing that milky, waxy secretion. And in fact, their spurs are actually covered in a skin flap. So theirs aren't even exposed the same way that platypus spurs are. So theirs could still be used for maybe scent marking or something to that degree, but there wasn't any solid info on why they might still have these spurs since they no longer have venom. Another thing that's unique about monotremes is they lack teeth. They do not have teeth as adults. Echidnas are toothless, period. They have no teeth. Their jaws are just long, thin bones. Nothing on the surface, really. They are just for them to be able to open enough to stick their tongue out and slurp up small invertebrates.
Yep. Like an anteater.
Like an anteater. So they've got nothing going on tooth-wise. The platypus is a little more complicated. They have teeth as young that they will then lose into adulthood. So like us, they start with baby teeth, but then when they shed those baby teeth, there's nothing there to
they're
replace.
done. That's
they're
it.
done. That's the only set of teeth they have. What they do then have is keratin pads in the mouth that are grinding pads that they use to still chew their food. which makes them incredibly weird for toothless animals, but mammals especially, in that they have no teeth but still chew.
Yes, they have a replacement for a thing that is doing a similar thing to teeth. They have a pad. It makes me think of like a stingray.
Yeah.
And in those, it's a tooth.
Yes.
But it's this flat.
It's kind of like sandpaper. If you put sandpaper on your jaw instead of teeth so you could grind your stuff.
Yeah.
You're not crushing it, but you're able to grind it up. They have that instead of teeth, and they will use that to chew up their prey. But they'll do that once they've caught it underwater and then bring it back to the shore to chew it. They have cheek pouches to store their prey when they catch it underwater, which I didn't know.
Cool.
All right. Now, this is where we get into a divergence of the two groups, in that the platypus is a swimming animal. They are semi-aquatic, highly tied to the water. Echidnas are terrestrial. They can still swim like many animals can, but they are terrestrial, walking around digging. The platypus does have a unique way of swimming in that they use their front limbs as their main propulsion.
Mm-hmm.
So with their arms off to the side, paddling with their front limbs, and then using the back legs as rudders, which is unusual for swimming mammals. Most swimming mammals kick with the back.
Yeah, they use their tail or their feet to push forward.
The first thing this made me think of is that it makes them more similar to like a sea lion
Yes.
than anything else, which is just not the comparison you usually hear of with monotremes. Platypus senses are also specialized for the water. We already talked about their electrosense, which they use to hunt for prey. Even though the amount of electricity produced by their prey items seems to typically be too low for their electrosensors to detect, it's thought that just the amount of electrosensors they have make up for that and allow them to find their prey. So they just have a bunch of not particularly strong sensors, but strong enough and enough of them to find prey in murky water with their eyes, ears, and nose closed. So they are hunting completely by touch and electrosense, not using sight, sound, or smell, at least through their nostrils, because their eyes and ears on their head are in folds, in kind of a furrow on the head of skin that can close over the ears and eyes. So they don't just close their eyes, they fold their head, their face, over their eye and ear to shut it out while they're underwater. Their nostrils can shut, so they are sealed up and just sensing with that bill. There is evidence that they might have a functional Jacobson's organ or vomeral nasal organ in the upper side of the bill, so that they may be able to sense chemicals that way and get a sort of sense of smell while underwater. But there's no sign that they have any way to transmit sound from the water to their inner ear. So they are flying blind and deaf while they're underwater, just using sense of touch and electroreception, sweeping their bill. They sweep it like you sweep a metal detector across the beach, finding that prey. One of the reasons this is notable and kind of weird is that their eyes do show adaptations for underwater sight, but it doesn't seem that they are typically using them whilst underwater most of the time. So they have corneas very similar to adaptations we see in seals, with a flattened surface for underwater sight, and have decent vision, not particularly amazing, but, effective vision. But all evidence seems to suggest they're not using it during hunting. So that may be something that ancestral platypuses were using more underwater, and they've retained. Echidnas, on the other hand, as we mentioned, are typically hunting more like an anteater, tearing into logs and anthills to then slurp them up with sticky tongues. They don't have any sort of chewing pads, but they will grind food up between the bottom of their mouths and their tongue. So they will crush up those invertebrates that way. They have much more specialization. They have much more notable specializations for digging, with powerful mole-like claws and strong front limbs. Their back limbs are kind of turned out to the side, their back feet, with backwards curving claws that are noted to be used for grooming, but also can be used while digging to help push the dirt out of the way. They also are famous for their spines, which we mentioned, and they'll use these in defense. They will also dig when they're feeling threatened, just dig down quickly to try to get away or under something. But if they're not able to dig or caught out in the open, they can roll up like a hedgehog and make a ball of spines. And it's been noted that they are not preyed upon very often because of this. They seem to have a very effective defense against the predators they share their territories with. Short-beaked echidnas are also noted to have fluctuating body temperatures, which is just a slightly unique thing for them. They'll go into torpor or kind of a hibernation state throughout the seasons of their year and can become very sluggish in very high or very cold temperatures. So they are just notable for not having quite as consistent a body temperature as a lot of other mammals that we think of. I also found one thing noting that they actually have been studied for intelligence and learning abilities, and that they've actually tested similar to rats and cats.
Interesting, which is another thing that you wouldn't expect necessarily from the group of mammals that has all of these ancestral-seeming features. But,
Precisely.
Of course, then again, we also find more and more signs of intelligence as we measure it all across the family tree of life.
Yep. And then the final weird thing to say about monotremes is that very, very recently, and this is not the first time we've talked about this, platypuses have been found to biofluoresce, in that they glow green under UV light. This was found out with museum specimens, so I don't know if it's yet been detected in living platypus, but they found that these platypus specimens, which was a female and 2 males based on presence of spurs, under normal light are just the brown coat that they typically have, and under UV light glowed green or cyan green, or cyan, and that the male and female glowed similarly. So this doesn't seem to be sexually dimorphic, which to them suggested that it's not a trait for communicating between platypuses, but likely for communicating somehow with other species, or potentially, as we mentioned in the bioluminescence and fluorescence episode,
157,
it could be a way to hide from predators that have UV sensitive eyesight. We see UV in lots of nocturnal and crepuscular, which are active at the beginnings and ends of the day, sunset and sunrise, and all other biofluorescent mammals that we have discovered so far are active during those times of day. So it very likely could be a low light adaptation for animals with specialized UV vision. This might throw off their detection of you and help you hide in plain sight by glowing, which is weird and just adds to the list of odd traits they have.
Monotremes are fascinating for all sorts of reasons, as we have up until now been discussing. One of the things that I think is always super fun about monotremes is that they are both obviously and non-obviously weird.
Yes.
Like, platypuses are famous for being weird animals. People look at them, that's a weird animal.
At a glance, they don't look like other animals.
Right. It's got a weird duck-like bill. It's got that beaver-like tail. They're odd in their various features. It seems pretty intuitive to people. They go, that's a weird animal. And so often when that happens, it's a case where we can be, well, okay, actually, that's not that weird. Actually, there's a lot more normal, quote-unquote, things to be had. With platypuses, it's like, oh, you have no idea.
Oh, yeah.
They're weird all the way down.
Yep.
It never stops being weird with platypuses. And echidnas. Echidnas are very strange. And again, a lot of that, this is always that balance that we've talked about with many other groups. In some ways, it's the obvious reasons that this is an outgroup of mammals. They have features that are different from all other mammals because they are a different group. They've evolved in a different trajectory. They've retained a lot of those older features. But also, this is a small number of living species that are highly specialized to a particular lifestyle.
Yes, on islands quite often.
Yeah, the platypus is not only this outgroup of mammals, it's also living in a way that very few other animals in the world do. So that weirdness is this combination of being weird for mammals because of the lineage that you're in, but also you're doing something weird. You are adapted in ways that are strange. So platypuses and echidnas have weird from both directions.
Yeah, and that's a key aspect to a lot of the research on them is, are you weird because you're outside these other groups? Or are you weird because you're doing something weird?
Right.
And then back and forth. Are you doing something weird because you are outside this group, so you had some trait that let you do, and it can be very hard to tack down where each source of weirdness is coming from evolutionarily. They're even weird down to their genes. Their chromosomes are different than marsupials and placentals. More similarities with marsupials, but they do have like an organization that's fairly different than what we typically think of, with several large chromosomes and many smaller chromosomes instead of relatively equal or similar sized chromosomes, and notably complex sex chromosomes.
Interesting.
That are distinct from placental sex chromosomes.
And this gets at one of the reasons that we get really excited about groups like this. Why tuataras are interesting for people who study lizards. Why lobe-finned fish are interesting for people who study the evolution of vertebrates on land, is these are groups that we can look at and make inferences about the evolution of these groups. Monotremes might give us clues to the early evolution of mammals, the ancestors of the rest of mammals. But they also live in very particular ways, so they can give us clues as to how animals adapt to those things. And so, like you said, a lot of research in them is trying to tease those factors apart. How much of this is actually representative of mammal ancestry? Are you like sloths, where the one group that you still have living today is actually a really weird representation of the overall group, that just the only ones that survive to today are the weird ones? How many of your features are modern monotreme features, and how many of them are ancestral monotreme features?
Yes.
How much do you teach us about the ancestry of mammals? So that weirdness is super fun. It's not only the reason they show up in documentaries because they're weird and people like weird stuff. That's also the reason why researchers are so interested in them, specifically because they're very strange compared to other mammals.
Yeah, it gives us a comparison. And so after the break, we'll talk a bit about the evolutionary history, or what potentially we think the evolutionary history of this group is, and some of the ways we've found interesting comparisons in their evolution and mammals in general. As is so often the case with modern, small, weird groups, their fossil record is more diverse and more widespread than they are today.
Sure.
But not by jumps and leaps and magnitudes.
Right. We're not swimming through monotreme fossils.
We aren't. Most monotreme fossils are still restricted to Australia.
Mm-hmm.
And that is where we find the vast majority of them. There are some in the surrounding area of just Australasia, but that area of the world is where most are found, with a couple, literally a couple, found in South America.
Yep. This was in the news not too long ago.
Yes, it was.
The second one was identified this year.
Yep. In total, there's roughly, give or take, 11 extinct genera ranging from the early Cretaceous up to the Pleistocene, and they are found in Australia, New Guinea, and South America, and that's it.
Yeah, this is a group that seems by their fossil record to have been similarly... This is like when we talked about Sicilians.
Yep.
Modern Sicilians are all tropical, and also so is their fossil record.
Yes.
This seems to be a limitation that isn't unique to just the living groups.
It has often been considered that they are a Gondwana group, which is those southern continents when they split from the northern continents, that monotremes were isolated to the southern hemisphere and spent most of their evolutionary history in the eastern section of that, in or toward Australia.
Mm-hmm.
Now, of course, we lack fossil record from Antarctica, which they would have need to be traveling through.
Right.
So there could be a robust monotreme fossil record there.
Maybe that's where they all are.
But we have not been able to get to that. So
that's where the giant platypuses lived.
Right?
Maybe.
Monotreme evolution, the origins of monotremes is pretty murky. We do not have a solid grasp on which group of mammals they evolved from, so there's still a lot of research and debate going into that. It is solidly thought that their origins are in the Mesozoic, and a lot of studies estimating this origin and split from other mammals puts it probably in the Jurassic, though we'd have no fossils from the Jurassic.
Okay. So up in the range of 150 million years ago, maybe earlier.
Yes. All of our earliest fossils are from the Cretaceous, but likely they split before that. The first monotreme was likely not fully platypus or echidna-like, but there is some debate as to what the earliest monotremes were like.
Mm-hmm.
One of the popular hypotheses about their origins is that they came from that Australosphenida group. This group is a Gondwanan group of mammals found in Australia, South America, and some in Madagascar. They are notable for having tribosphenic molars, 3 tipped molars, basically, with 3 bumps or prominent bumps on them that were noteworthy for being good at both grinding and shearing abilities, so having multiple functions to the molar. These molars are known from other groups and had been thought to evolve only once in therian mammals, marsupials and placentals, with these potentially being convergent to those, so another origin of this kind of tooth, with some even suggesting a split of the Australosphenida and a Boreosphenida group.
A southern one and a northern one.
Exactly, splitting the other members of that tribosphenic tooth and monotremes with metatherians and eutherians up north. But some reevaluations have brought this into question and really questioned any connection at all between monotremes in this group.
Mm-hmm.
So some noting that none of the members of Australosphenids possess what's known as an enlarged dental canal, which is a notable thing in monotremes, which houses the nerves for their very sensitive snouts.
Gotcha.
This is a characteristic thing found in most monotremes,
Right. This
extant and fossil.
Right, not just platypuses and echidnas with this electroreception, but their ancestors, their ancient cousins. This is a thing that is common through this lineage.
What we would call a synapomorphy. That this group doesn't seem to have that. They also note differing numbers of teeth, and that all known southern hemisphere tribosphenic mammals have 3 molars, while the earliest known monotremes have 5, and would have had to gain molars to evolve from this group.
So this is a common feature, especially with something like monotremes, where we find where and when they seem to have originated and go, what were the prominent groups then?
Mm-hmm.
Which ones do they fit with?
Yes.
And a lot of it comes down to these questions of numbers of teeth, types of teeth, features in the skull, trying to link those ancient features to determine that relationship.
Yes. And so this has been brought in question mostly because of those teeth, that early monotremes don't show the tribosphenic 3 bumped tooth and have more teeth than this group.
Right.
So they would have needed to have lost that feature and gained teeth. Right. So many researchers have leaned away from this, but you will still see this association come up in taxonomic and studies on monotremes.
And it's tough because not only do we not have a ton of fossils of groups like monotremes, but also, and this is just me shooting in the dark, but I bet I'm right, we probably don't have a whole great fossil record of Australosphenids and other Mesozoic mammal groups in general.
Because Mesozoic mammal fossil record is not the most robust.
No. Which means that we are working with limited data.
Yep. As far as when monotremes first showed up, once again, estimates put it in the Jurassic. Differing techniques have placed it anywhere from 217 million years ago to 187 million years ago, but hovering around that 200 million years old.
Sure. Not too dissimilar from the origin of mammals proper.
Yes.
So this would have been an early branching group off of mammals.
Absolutely. We don't get our oldest, clearly monotreme-like fossils until the early Cretaceous, 126 million years ago, in Australia, with Taenolophus trusselleri. This is the oldest known member of monotremes, and is distinct. It has 5 molars. It also is itty-bitty, like shrew-sized.
Oh, wow.
This is teeny tiny.
Yeah. I mean, modern monotremes are not huge as we do. We're talking like, kitten to cat size. Shrew is very small.
This is very small, unusually small for monotreme fossil record. Like, there are no other member that we're going to list has been described that small, even close.
Gotcha. So maybe they started very small,
Mm-hmm.
or this was a small branch.
Yeah, this could have been a very specialized. They've described it. I've seen it described as mouse-sized, shrew-sized, and gopher-like. So this could have been living a very unmonotreme-like lifestyle.
Yeah.
Compared to later members. There is another genus from around the same time, which is Sturtodon elizabethae, which some have referred to the same group as this early member, but is actually quite a bit bigger. Exceptionally large tooth, I saw one of the things described. Now, many of the descriptions will be on the description of the teeth, because most monotreme fossils are jaw fossils.
Right.
Fragmentary and toothed fossils.
Which is true about most Mesozoic mammal fossils in general.
Precisely.
That tends to be how we identify and classify Mesozoic mammals and mammals in general, so we often are talking about just jaws and teeth.
Yep. We do have some others from around that same time of, hovering just before 100 million years ago. Genuses like Cryorichtes and Sundrius, both of which date to 113 to 108 million years ago. Still only in Australia. So far, our fossil record is still only in that part of the world. As we keep going, about 100 to 96 million years ago, we get some with a bit more robust descriptions. There is a whole group that have been debated whether they should be in monotremes, but are often grouped at least very close to monotremes, if not early members of monotremes, is Chalicodon, or the Chalicodonids. These were relatively large for Mesozoic mammals. Potential body lengths I found were up to a meter. So, these could have been among some of the biggest Mesozoic mammals, Cretaceous mammals. They also had unique molars. They were described as bunodont, meaning that they are typically flat and good for robust, tough food.
Right. Bumpy teeth, like our teeth are bunodont.
Mm-hmm. These are often described as durophagous, probably either vegetarian, eating plant material that's tough, or shellfish type material.
Chewing on hard stuff.
Is also very interesting and unusual. Their teeth are so distinctive that they have what was called a hot cross bun shape to it.
Oh, weird.
And were almost named Hot Cross Bonodon.
Somebody nixed that idea, I guess.
They do have that mandibular canal, but it is smaller, which could be due to their more notable dentition, leaving less room for a notable nerve pathway.
Okay.
So their specialization might have leaned them slightly more away from the monotreme nerve path.
Sure. I wonder if also perhaps it was just ancestrally not as prominent and became more prominent towards more modern groups.
And as I said, originally described as monotreme, but some have suggested that it is different enough it should be in a different group.
Yeah, maybe an offshoot.
Yeah. So this one you'll often see listed with, but sometimes you'll see them kind of listed alongside monotremes as Mesozoic mammals. Another from around the same time, about 108 to 103 million years ago, is Steropodon galmani, which is often called the oldest platypus.
Ooh, so not just monotreme, but now potentially one of our familiar families.
Yes. Now, they do say it is probably not the same branch as modern platypus, not an ornithorhynchid, but maybe ancestral.
Okay, so platypus, near platypus,
yes,
or similar to platypuses.
But it does have very similar features. It might have even had similar dentition, so it could have been living a near platypus-like lifestyle. Though it was notably larger, like cat-sized.
Interesting.
So this was a beefier platypus, or as some have described it, proto-platypus. That it does seem to be much closer to a platypus shape than some of these earlier monotremes, or at least confirmable that this was likely more similar in shape.
Now, I assume at this point we're still talking about mostly teeth and jaw fragments.
Yes.
So these connections are being made from shapes of small bits.
Yeah, we don't have the full body of any of these to my knowledge. I think some of them have like a humerus here and there, or a leg bone, but we do not have complete specimens of any of these, at least that I saw noted in any of the research.
Yeah, a lot of this is partial material. So making those comparisons with modern species is an inference made from relatively little material.
That we're seeing similarities to what we have to the modern platypus, but there could be all sorts of things going on in the rest of the body that we don't have preserved.
Right. If you find a platypus-like skull, you'll know.
Yes.
Platypus skull, hopefully we'll get a picture of one for the blog post. Platypus skulls are very strange looking.
Absolutely.
It looks like mandibles.
Yes.
Sticking out of the face.
They are, as bird-like as they look on the outside, they do not look on the inside.
They look like Zerg on the inside.
And at this point in the fossil record, we hit a gap of about 50 million years without monotreme-like fossils.
They just took a break.
Yeah. So we just have this gap. And then the next oldest ones we have are the South American fossils.
Gotcha.
So there is this jump from the mid-ish Cretaceous up to the end Cretaceous or early Paleocene.
Mm-hmm.
There are only 2 monotremes known from South America. These are the only ones outside of Australia or New Guinea. The oldest being Patagorhynchus pasquali, which is from Patagonia.
Mm-hmm. That's the one that was in the news very recently.
This is one of the most recent new fossil monotremes. They dated it to about 70 million years old.
Just before the end of the Cretaceous.
Still fragmentary jaw and lower molar. So we do have molars still. Based on where it was found, it likely was near and potentially inhabited lakes and ponds because it was found with material of aquatic mollusks and some aquatic invertebrates.
If I remember correctly, they said, based on the minute features and shape of the jaw piece and the habitat, it is at least within the realm of reason that it could have been living similar to platypuses.
Yes, one of the ways that it was worded was it is congruent with a duck-billed morphology. In that this shape of tooth...
We don't have a duck bill, but this tooth would fit in a duck-like bill...
Quite well.
Perfectly well, yeah.
So, once again, a maybe platypus-shaped ancestor or relative, now in South America. Another one from South America... The other one from South America is Monotrematum sudamericanum, which is slightly younger. Now we're in the Paleocene, 63 to 61 million years old.
Just after the Cretaceous.
Yep. This is in Argentina and is a bit bigger than your average monotreme. It's described as around twice the size of another fossil species, Obdurodon, which is the next fossil group that we come across in our travels through their history after yet another gap, about 38 million year gap without fossils. So there's a lot of notable absences in the fossil record where we just don't get a glimpse into what's happening during that time, at least not yet.
And when we do get a glimpse, up until this point in our story so far, they are tiny glimpses.
Yes.
They are teeth and jaw fragments. Enough to say monotreme, but not enough to say a whole lot beyond that.
Yep. This next group of monotremes is about 25 million years old. And so we are now getting into the Miocene, and we're back in Australia.
Mm-hmm.
Obdurodon is a group with at least 4 species, though I can only find 3 names, so that might have been an older listing.
Interesting.
So 3 species for sure that date from the Oligocene across the Miocene, with the oldest being 26 million years old in the late Oligocene, and then we have another that's 15 million years old, and yet another that's 15 to 5 million years old.
All right.
So we have a spread of this group, and these are often described as platypus.
And I was going to say, that it doesn't surprise me that this Miocene range is where we would see something more recognizable, because that is the time period where we are getting recognizable members of most modern mammal groups.
Yes.
This is where you would look at an ecosystem during the Miocene in most parts of the world and kind of recognize the animals you're seeing.
Yes. So, this is now... I often see this grouped with platypuses as just another genus of platypus.
Right. That's extinct, not just monotreme, platypus.
Platypus. And they definitely seem to have the bill. We have some complete skulls that show a platypus-like bill.
Cool. They got that mandible.
Yep. They have
I keep saying mandible. I mean insect mandible.
Yeah,
that's
exactly,
what
right?
Because it's this sort of 2 hooks facing each other shape of a platypus skull with a gap in the middle where it looks like a praying mantis's mouth parts or something.
Yep. Yeah, no, they have a very platypus-like skull now. Still different, but likely not due to not quite being there to, acting platypus-ish, but doing a different kind of platypus thing. Some have noted that their bill deflects more upward instead of downward, like we see in today's platypus, which could suggest a different type of feeding.
Yeah.
And when they looked at it morphologically, it lined up better with an open water feeding, swimming and catching things in the water, than a bottom-dwelling feeding. And so Obdurodons may have been swimming more actively up and down the water column, catching stuff with this bill. This is also supported by they have a less prominent mandibular canal for their nerves. Right. So they
less
likely
reliant on that electroreception.
Yes.
These would have been aquatic hunting, like swimming hunting.
Yeah, more like an otter than sweeping the bottom like a minesweeper. And this could also be one of the reasons we see a difference in their dentition. Obdurodons still had teeth. Adult
teeth. Yeah, the whole life up into adulthood.
And this could be why we see a lack of teeth in today's platypus, is as they got more sensitive bills and swelled that neural canal, it may have not left room for tooth roots. It may have started to get in the way of having rooted teeth, and then they had to rely on that keratin pad.
Interesting.
So this difference in feeding behavior could be one of the reasons we see a difference in teeth between these groups.
That's very strange.
Right?
That's fascinating. Well, as we've talked about before, anytime a group of animals develops a feature that creates a trade-off at the expense of the thing that their lineage is known for.
Yep.
Mammal teeth are highly specialized. We've talked about this a whole bunch of times. The idea that a group of mammals would evolve senses so specialized that they had to get rid of their teeth in order to use it, very strange, if true.
Which, though as strange as that seems, tooth reduction is a trend across monotremes as a group.
And we do see tooth reduction happens in a bunch of different groups of mammals. I don't want to, we don't want to focus in on our monotremes and make it seem like they're the only ones doing these things. Like we mentioned before, anteaters famously are mammals that have reduced their teeth a lot. There are a bunch of different examples. Monotremes are notable because the modern ones all seem to have done that.
Yes. And we do see a trend. If you look at the fossil record, you'll note that the earliest had 5 molars, and then we go down to 4, and then 3, and we see a continuous reduction. And eventually it's just 2 on the upper and 3 on the lower with Obdurodon, and then only in juveniles in the modern platypus.
Cool. Which is a really wonderful transition to get to see, and a really neat example of a clear sequence of evolutionary process in the fossil record, even with a fairly scarce fossil record.
Yes, exactly.
That all we have, for the most part, is teeth, but that's enough to show patterns in teeth.
Yep. So, like, Obdurodon still had reduced dentition, just compared to today's platypus, they had tons of teeth.
Right. This was a toothy platypus.
All total 10 of them. They also did know that Obdurodon still did have that neural canal, so they probably still had a sensitive bill, just not as sensitive and hard to say whether electrosensitive.
Right.
But just not as sensitive as today's platypus does. And then with that, we now come to our modern groups, where we see yet another gap, because our modern groups don't have a fossil record until fairly recently. Today's platypus, molecular dating suggests that it showed up around 0.7 to 0.8 million years ago, so
very recent.
Very recently.
Mid-Ice Age.
And echidnas do not have a fossil record that we have detected until, at the very potentially earliest, the Miocene, but mostly Pleistocene.
Interesting. So during the Ice Age is where we see echidnas show up.
And so they just kind of pop up in the fossil record. We do have some notable fossil echidnas. There are members of the long-beaked, or maybe closely related to the long-beaked echidnas. Things like Megalibguilia robusta, which is the one that might be as old as Miocene.
Okay, possibly an ancient echidna.
Yes, that's as ancient as it seems echidnas get, according to the fossils we have. This genus did have a decent distribution with another one of their species, Oweni, found in both Australia and Tasmania. Based on their broader skull, it's thought that they might have been more specialized for things like insect larvae, and more beefy, juicy inverts instead of just the tiny ants and worms. They didn't have that long, slender skull, but a shorter, broader skull. But by far, the most famous fossil echidna is what was Zaglosus hacketi, but now often you'll see it named Murrayglossus hacketi, having fairly recently been at least suggested to be put into its own genus based on enough differences. This is the largest known monotreme.
Giant echidna.
This is the giant echidna.
All right, tell me how giant we're talking.
1 meter long.
Oh, all right. That's actually pretty big.
Yeah. This is
so often when we talk about the giant of a thing, it's like, well, yeah, but today's version is like 3 centimeters long. Yeah. So technically, no, 1 meter long, that's actually pretty sizable.
This would be an echidna that would be hard to give walks to because it would just pull you around probably. They're beefy animals. This very much is still shaped like an echidna with robust limbs, but meter long.
So you'd gone for a walk, and people would walk by and just see your leash disappearing into the ground.
just like the lines going off of its jaws across the water.
Yes, yep.
They noted that it probably did stand a little taller, proportionally than other echidnas, so it probably had a more upright stance.
Right. Not upright like on back 2 feet, but like limbs a bit straighter.
Yes, exactly. It was likely 50% heavier than today's biggest echidnas, which would mean it would have a mass of about 20 to 30 kilograms or 40 to 60 pounds.
All right.
So
that's a big monotreme.
This is a monotreme.
Yeah.
It also had some unique features in some of its leg bones. It had shortened tibias and relatively long femurs, which these features of the back leg might have given it the ability to raise up on the back legs for temporary bipedality.
Mm-hmm.
Most likely to then be able to like claw into mounds or even into trees. We do see today's echidnas take a similar stance, and with the size of this echidna, it would have allowed them to reach potentially arboreal termites, ones that were nesting in the trees.
Were these echidnas on their way to being ground sloths?
Right? Like, it sure does sound like it.
Getting closer and closer.
I did see one thing that even suggested that maybe they were climbing the trees. Mm-hmm. We do see today's echidnas, like, climb fences and trees at times.
Yeah. And 50 pounds is big for a monotreme, but certainly not too big to exclude you from getting up a tree.
Absolutely. I saw one thing that noted that we might have been seeing niche partitioning, especially if any of the modern echidnas overlapped with any of these fossil ones.
Oh, yeah.
That today's echidnas could have been terrestrial feeders on colonial invertebrates, ants and termites.
Mm-hmm.
Your megalobiguilias could have been terrestrial, but feeding on large soil invertebrates, grubs and stuff like that. And then Murray-glossus could have been a scansorial or arboreal feeder of colonial insects.
Yeah. Now, I think that we got onto size and I distracted you from potentially saying Murray-glossus, the giant one, is Ice Age, I assume?
Yes, that is Pleistocene. And so this is a fairly recent.
Mm-hmm.
So
could have overlapped with modern lineage, the modern groups of echidnas.
And we do have some fossil record of modern groups. It sounded like at least with long-beaked echidnas, there was note of some fossils in New Guinea, but not a robust fossil record for today's echidnas. And this lack of echidna fossil record has brought up some questions as to what does this indicate about their evolution?
Yeah, where were the echidnas?
Mm-hmm. Because some estimates for the divergence between echidnas and platypuses has put their common ancestor at like as old as 90 million years ago, but some have said as recently as 17 million years ago. So the estimates are unsure as to when those two split. And with this recent occurrence of fossils, that could mean they are a fairly recent group. But it has been noted that they are also very potentially poorly fossilizable.
Right.
They lack teeth. And as a group, they don't even show the juvenile teeth that platypuses have. Mm-hmm. They just don't have teeth. So they lack that ideal fossilizable element.
If you're being fossilized as fragments, if some of those fragments are teeth, we can still work with it for mammals. But if there's no teeth and it's just fragments, they are likely to either not be fossilized at all or just make it to us as piece of bone.
Yes, exactly. They also often live in habitats that aren't typically ideal. Like long-beaked echidnas are very famous for living in moist forests.
Right.
So like that is not an ideal habitat to fossilize.
Platypuses are swimming in lakes and rivers or whatever.
Yep.
Where fossils are being collected.
Nice and silty where you can preserve stuff. And so it's been, debated as to what exactly the history of echidnas looks like. The restriction of environments definitely could be a player, but others have pointed out, it's like, yeah, but the shortbeak today is more widely distributed than any Australian mammal.
Yeah.
So that seems weird.
It could be part of it.
Yeah, but surely some of them were in, like, we find them in deserts in places where they very well could have been preserved in a nice dry habitat. So there doesn't seem to be a clean answer. One suggestion I found is that they may have evolved in a more isolated place and then moved into Australia. Specifically, the suggestion that was given was Malaysia, and that they could have evolved on New Guinea, where we now find the longbeaks isolated, and taken an echidna-like shape there, and then eventually moved over to Australia and spread out.
Yeah.
So they could have a longer history in a more isolated place.
Right. Their early history might be specifically in a spot that they weren't leaving very many fossils.
Exactly. Though yet another suggestion is that they might have a longer history but didn't look like echidnas, because many suggest that the original monotreme body shape, or at least earlier one, was platypus shaped.
Yeah.
And that we could have found early echidna ancestors, but they were shaped like platypuses.
Right. Which is that came up when we talked about this in the news. The suggestion that some of the features that we associate with platypuses seem to go back quite a ways in the fossil record, which might indicate that platypus-like body shape, platypus-like lifestyle might be something that has been a monotreme feature for a long time, which is extremely unexpected in how strange that suggestion is. We are so used to thinking of platypuses as this super weird, one-off, bizarre member of this group. The suggestion that that might be what monotremes have looked like for the past 100 million years is very cool.
Absolutely, and it has gone so far that some have suggested an aquatic origins for monotremes.
Ooh.
That we might have monotremes the way they are because this branch started with a at least near or semi-aquatic lifestyle.
Yeah, like modern platypuses.
There are a number of supporting lines of evidence for this. One being that a lot of platypus-like features go back very early into the fossil record, all the way back to the earliest monotreme fossil we have, has that nerve canal that is a very platypus feature. We see the reduction in teeth toward that more like lifestyle across the group. And we see a number of oddly overlapping features with echidnas and platypuses, both being electroreceptive, a feature that would be very unusual to evolve for a fully terrestrial lineage.
Right. It's a little weird that echidnas have it, but if they inherited it from more aquatic dwelling ancestors, that might explain it.
Absolutely. And there's something that we could have seen reduced in echidnas and potentially other groups like the colicodontids, which also had that reduced nerve canal and more robust teeth. This has been suggested quite often, and you will see it listed much more resolutely as echidnas came from platypus-like ancestors, and then that's as much discussion as that topic is given in some descriptions. So this is held by certain researchers. But there has been questions brought up because this would make echidnas secondarily terrestrial mammals.
Right, that they became semi-aquatic ancestrally and then moved out of being semi-aquatic, which has happened before.
Yes. And there are some things that seem to suggest that. Electroreception is one of them. Some have pointed to their flattened body being a very hydrodynamic body shape that is similar to the platypus's body shape. They also have their backwards facing feet. They're sideways facing feet, which could be from the rudder-like feet position of the platypus. They also use their forelimbs as their dominant mode of walking, like that's their most powerful forward motion, like the swimming position of platypuses. One paper called it front wheel drive, that they are both front wheel drive movers.
Interesting.
And so these traits connect the two and would be, as one paper put it, highly anomalous for a fully terrestrial lineage.
Yeah.
That some of these seem really weird if you've been on land the whole time. Why are you doing it so differently? And as mentioned, despite their appearance, echidnas can swim. So they absolutely can swim. So there are some connectors, but others have pointed out that there are answers for those other than aquatic.
Right. That's not the only potential explanation.
A lot of them can be connected just to digging lifestyle. The flattened body and the front wheel drive are just, the moles do that. Those are very digging adaptations, which could also be pointed at the platypus, which is also a semi-fossorial, a digging animal.
Yes. That maybe they were ancestrally diggers, and the platypus inherited some of those features in its move to the water.
Exactly. So digging can answer some of that. They pointed that the unusual position of the back feet doesn't hold up since the platypus does not hold its feet that way while it's walking. Only while it's using them as rudders. So that might not hold up as well. And they've noted that focus on electroreception ignores all the specializations echidnas have. in that they have extremely strong tactile and olfactory specializations. Olfactory, smell specializations and adaptations both in their brain and the structure of their snout that are missing in platypus. So they have their own specializations that aren't just derived from platypus.
Right. They're not just the cousins of the platypus. They're their own thing.
Mm-hmm.
They've specialized their own way.
And much like was mentioned in that news about diving birds, it's been noted that highly specialized taxa, like the platypus, very rarely in the fossil record give rise to new, extremely differently specialized taxa.
Mm-hmm.
That it would be kind of weird for something as seemingly specialized as the platypus to give rise to a completely differently specialized and adapted group like the echidnas.
Yeah.
We don't see that happen very often in just the evolution of life.
Yeah. Although, I guess it's worth pointing out that if the suggestion is correct, that platypus has been kind of the standard form of monotreme for a long time, maybe that would make it more likely that you'd get a weird offshoot.
Maybe it's not as specialized as we might be considering it to be.
Right. All of this is to say, I guess, that monotreme evolution is very mysterious.
Yeah. And there's a bunch of examples of one paper coming out and being like, aquatic origins for echidnas. And then that same year, a paper coming out and being like, response
Yes.
to paper of aquatic origins.
Disagree.
Yep. That happens quite a bit with monotreme. I found at least like 2 or 3 examples of me coming across a paper and then coming across the same title but with response in front of it.
Yep. One thing that I started thinking when we talked about the sort of platypus body shape and all that, and then thought it harder and harder as we talked more about the relationship with echidnas, is that if that view is correct, and that's an if, that makes platypuses unexpectedly similar in many ways to crocodilians.
Right?
That is the platypus shape, the croc shape.
Yes.
For monotremes, and then they had terrestrial offshoots. Just our platypuses, the crocodilians of monotremes.
I say yes.
There's always been a platypus shape for the whole history of them, and the ones who moved on to land are the weird ones.
Right? Yeah. It is so, jarring almost going through the fossil record and history of monotremes to realize how many of their weird things are not, get less and less weird as you keep going back and you go, so you've been doing this the whole time.
Yeah, this isn't, like I brought up earlier, this doesn't seem to be the same situation as sloths, where sloths, for most of their history, were kind of normal. Like they lived kind of like bears, or they were not utterly bizarre.
Yeah, still unique, but they functioned in roles similar to other animals.
Yeah, tree sloths are weird.
That is super, super unusual.
That's a specific group that did a weird thing. Monotremes are sounding a bit more like turtles.
Yeah.
That's a very weird thing to do.
Yes.
Everything about a turtle, that's a very strange thing to do. But you started doing it 200 million years ago and then just ran with it.
Yeah, we've had turtle since then, and it seems like we may have had something close to platypus for the last 100 million years.
Yeah.
And that's just been a fact of the planet since then.
And I love that because so often, and this is a generalization, we point at a shape, we point at croc, and we point at shark, and we go, that is a shape that has been consistent, not unchanging, but that general shape, that general lifestyle has been around for crocs, it's 250 million years, for sharks it's 400 million years, whatever. It's working. What a winning strategy. The shape of a shark, the general concept of a shark. The notion that is also true about platypuses is a delight. It's so delightful that it makes me a little bit extra cautious about accepting that interpretation.
Right.
Because I can feel how much I want it to be true.
Yes, yeah.
I am very biased because I would love for that to be the truth.
It is potentially too pleasing.
Yes, that might be too satisfying to be true.
Well, and especially with the idea of you could have had open water platypus and, stream platypus and bottom dwelling platypus. That shape evidently was more plastic and able to fit into diverse niches than we might expect only looking at today's.
Yeah.
This normality to monotreme stuff also potentially applies to their venom. We already mentioned that both echidnas and platypus have the spurs, so already suggesting that their ancestor likely had spurs as well, and potentially venom. Now, we do not have a robust fossil record for monotreme spurs because we mostly only have jaw fragments.
Right.
In fact, I don't think we have any fossils of spurs going back through the monotreme fossils. But, almost even more strangely, we do have several fossils of non-monotreme mammals that have potential evidence for this kind of delivery system of venom.
Huh.
Yep. So it could be, based on these other early mammals, that this similar back leg delivery system and specialization of these ankle bones could be an early mammal feature that was then lost in therians, lost in marsupials and placentals, and retained in monotremes.
That's fascinating, because that is also a thing that's been suggested for certain groups of lizards.
Mm-hmm.
That it may be that their ancestors were venomous and they lost it or reduced it.
Yep.
That early mammals, it may have been more common for there to be venom amongst them.
Yes.
And it, like eggs and milk sweat,
Yes,
is a thing that monotremes have held on to.
Yeah, exactly. So whether or not that was convergently evolved by multiple early mammals, or if it's something that was a feature of early mammals and then only hung on in monotremes, venom does seem to have a more... this really weird venom system does seem to be potentially more common, or at least the structure of the spur.
Right. That at least in platypuses has been co-opted for a venom delivery.
Exactly. So the venom might be unique to the platypus, but this spur, this weird ankle spur, is not unique to monotremes potentially, and might have been an early mammal feature.
Interesting.
There are other questions asked about early mammal evolution and looking at monotremes. Lots of things about the genome to try to get an idea of what the earliest mammal genome might have been like by comparing monotreme and placental mammal genomes together. There's also been questions about the transition from oviparity to viviparity, of egg laying to live birth.
Yep.
And noting things that there are distinctions between the way monotremes lay eggs and other egg-laying animals, that they have different things going on than, say, reptiles.
Yeah, and we talked about that in episode 154 about live birth.
So you will see monotremes studied in that regard quite often. One that I found studied and discussed quite a bit was ear bones.
Oh,
yeah.
Makes sense. That's one of the unique things about mammals.
We have our 3 ear bones, the malleus, the incus, and the stapes, that transfer sound from the eardrum to the inner ear.
Derived from ancestral jaw bones.
That used to be part of the joint of the lower jaw, and then over time transitioned from a joint sound job to just transmitting sound. Monotremes have the 3 ear bones, but they do have a slightly different arrangement and shape of the ear bones. Specifically, their incus and their malleus overlap more, and that they have more of an articulation than our ear bones and other placental mammals. This has been noted to be similar to the articulation found in some other early mammal groups found in the Jurassic. The Haramyidans, there was one recent study about a new specimen from this group with preserved ear bones that they noted being very similar to monotreme ear bones.
Oh, interesting. A lot of stuff's interesting this episode.
Yep. This potentially could make monotreme ear bones similar to ancestral mammal ear bones, depending on which version of ear bones is considered ancestral.
Right.
Which is what a lot of the debate has been about.
Is this a specialized different version of ear bones, or is it the classic standard?
And basically there are kind of 3 groupings of this joint. Overlapping joint, partial overlapping joint, and then the completely separate, just jointed version that we have. This paper suggested that the overlapping version was primitive. The monotreme version is primitive to Mammalia, and that the separate and partial overlapping evolved from that. Others have suggested that partial overlapping is primitive, and that overlapping and separate evolved from that.
Evolved, specialized in different directions.
Yes. So this has gone back and forth. Some have pointed out that partial overlapping, being the ancestral, takes less steps to get from cynodonts, the ancestors of mammals, to mammalian ears. Whilst others have questioned the validity of identifying those ear bones in that new specimen. So this one I found the paper, a response to that paper, and a response to that response. So whether or not monotreme ears represent the ancestral state or just another version of mammal ears is being cordially but somewhat aggressively debated.
Right. Currently, people are disagreeing about it right now.
So there are still features of monotremes that we're trying to decide how ancestral are you. And I found one really good paper that was focusing on their brains and was where a lot of that info about their intelligence and cognitive abilities came from.
Mm-hmm.
Noting that, and it was in quotes, that they're not primitive, just different.
Yeah.
That they are a mixture of primitive and derived traits, of ancestral and specialized traits, like all animals are.
Yes.
And that we need to stop categorizing them as a stand-in for early mammal, because there's as many things from early mammals as there are unique monotreme things mixed in together.
Which is a great summation. It is a fascinating aspect of the group, and it also is a little bit frustrating to our efforts to try to use monotremes to learn about mammal evolution, the deep history of mammal evolution. It means, like we said up at the top, we can't just look at monotremes and go, this must be what early mammals were like.
Yeah, obviously.
We have to tease those nuances out, and to do that, we rely on other information from the fossil record, information from other ancestral mammal groups, which is not always very abundant.
Yes.
So a lot of these questions remain up in the air, at least for now.
This is why you'll see so many comparative studies of comparing monotreme genome and placental mammal genome and comparing their features to say, okay, we both came from an ancestor. What differences are we noting? What similarities are we noting?
Mm-hmm.
That will help us maybe narrow down what was ancestral. And so there are definitely ways monotremes can help us investigate this question, but they are not the answer to this question.
Yeah. I like to imagine that there is just a treasure trove of fossil monotremes waiting for us in Antarctica.
I hope so.
That someday we'll get through that ice, and that's where they were all hiding.
Right?
That's where the echidnas are. They were all in Antarctica, waiting for us to find them.
Well, and because there's things that we don't have, other than our one tough-toothed group, there's none that seem to be herbivorous.
Mm-hmm.
They all seem to fit more in that insectivorous, or at least eating inverts group. So, were there big herbivorous monotremes that we don't have? Were there any, macro predatory ones that were taking down, were there weird monotremes?
Yeah.
Actually weird for monotremes, not just monotremes.
Or were they really just hyper-specialized, extremely rare, living in specific places, their whole history?
Yeah.
That, ask again in 100 years when we have a hopefully better monotreme fossil record.
Yes, and once, the Antarctica is bare of ice, as it will be.
We're working on it. Get the hair dryers. We'll get down there.
Yeah, so monotremes. Extremely, extremely interesting, extremely unique compared to today's life, but have been monotremes for a lot longer than you might suspect.
A fascinating and strange group of mammals. I love a group that defies the classification schemes that we've come up with. That for me has always been where the sort of the first time I learned about them and fell in love with this concept is egg-laying mammals. The mammals that seem to blur the edges between what we call mammals and what we call reptiles and birds. They're not. Mm-hmm. That's an inaccurate way to think of them evolutionarily. But they're not half reptile, but they do blur our classifications.
Yes, exactly.
Which is a wonderful entry point into learning about diversity of life and evolution. And I've used that before when I'm teaching these concepts. What a cool way to go. All right, let's talk about why these boxes don't work. Let's talk about how change happens from one group of organisms to the other. Allow me to pique your interest with this fuzzy egg-laying mammal.
Yes. Well, I also love that it seems like they've been doing this to humans for generations and generations.
Every new century has a new thing that monotremes are throwing us off about.
Well, and I found one story, one Dreamwalk story, I think they're called, about the platypus. That was a story of a duck who ends up getting kidnapped by, and I don't remember the term, but it was a rat-like being in their stories that kidnaps the duck, takes her as his wife, And then when she escapes and goes back home, she lays 2 eggs and gives birth to platypuses, a mixture of rat and duck traits, and has to get kicked out, and the platypuses end up in the mountains where they now live. And so, like, even back in that oral tradition, we were going, all right, we've got to explain this.
Something's weird here.
So there's got to be some explanation.
Well, and then there's the famous stories of early Western scientists seeing platypuses and not believing it right away.
Accusing falsification.
Was this stitched together? And then you cited those same groups of people not believing egg laying or milk production. Still to this day, where now we're going, is this normal?
Yeah.
Were we completely wrong? Is this actually like peak monotreme?
Yeah.
Is this nonsense hybrid creature?
Yes. And like, I also love the short-beaked echidna became one of my favorite animals during researching for this, because like it's doing so well and just throws in the face that typical mentality of, well, placental is, the obvious correct answer to being a mammal.
Right, inheriting the world.
Yeah, that's why we're everywhere. Sorry, marsupials and monotremes, you're doing it wrong. You need to get with the times and stop laying eggs and stop using pouches. But then you get stuff like the short-beaked echidna and like the opossum, which are like, no, we're really good at being animals.
Yeah.
We can keep doing it this other way, and we are going to be successful. Like, yes, that's awesome.
Yeah. So when placentals don't work out, possums and echidnas are going to take over the world.
I absolutely was immediately like, oh, so if the echidna's that successful, if I put it other places, what do we get like?
This is how you get owl bears.
Yes, it is.
Do you want owl bears? This is how you get owl bears.
Yes, I want owl bears. All right, let's wrap up our discussion. But before we wrap up the episode, one last category. We have our patron question. Every episode, we like to answer one of the questions that our patrons give to us. At a certain level, you can give us questions that we will answer here on the podcast. David, what is today's patron question?
Today's question comes from Noah. Does the average lifespan or generational cycle in a species affect the rate of evolution and the number of mutations that occur? Does this affect how rapidly species can adapt to new environments or new niches?
Very good question.
So if you live shorter lives or give rise to the next generation earlier, does that affect rate of evolution? Short answer is, yeah.
Yeah, absolutely. That can be a huge player in evolution and mutation rate for a species or population. Mainly just because even if you're not having more babies, in your litter or at one time, if you're having them more frequently, if your generations are shorter so that you're having them more often, that's just more chances for recombination. Mm-hmm. Every time you make a baby, you're recombinating genes and new traits can arise. But that's just more individuals that gives more chance for mutation and more chance for adaptation.
It also is more filter.
Yes.
So every time a population of organisms competes to give rise to the next generation, that is a filter that is potentially selecting for certain traits.
Selecting for who gets to breed and which of those young make it.
Yes. The more often that's happening, the stronger the selective pressures are going to be on that lineage. So yeah, you get faster mutation from just sexual reproduction and more frequent instances of competition giving rise to specific traits in the next generation.
Yes.
They're not the only factors.
No.
So you can have lineages that are long-lived or don't give birth very quickly that evolve unusually quickly, or vice versa.
Yes.
It's not the only factor, but it absolutely is a factor.
Yeah, there are definitely genetic aspects that will slow down or allow more mutations to occur. And so even if you're breeding quickly, but your genetics tend to slow down new mutations sticking around, it might balance out or just not make it quite as fast. Like, you won't see the exact same rate for fast breeding groups. You can still see variety, but absolutely breeding quickly and more often, and then especially if you have lots of young every time you do it.
Right.
That's why mice, that's why insects, that's why so many of those groups respond to changes so well and so quickly. That's why they can become immune to pesticides in just a number of generations, because they are leaning the statistics their way that enough will have the adaptation, will come upon the adaptation needed for that new scenario.
And this is one of the reasons why every time we talk about extinctions and rebound from extinctions or survival during extinction events, we mention the factor of body size, lifespan, generational cycle, because that slower reproductive rate makes it harder to adapt to major changes, which is one of the reasons why larger, longer-lived organisms, species, tend to do more poorly in the face of mass extinction compared to the little fast-reproducing ones.
Yeah, it makes me think of like policy change, where like if you have two organizations and one checks their policy every year and the other one is doing it on a decade basis, one is going to be responding to social changes just much more frequently because they are checking in and able to adapt, while the other one's going to come in and go, wow, a lot's changed.
What are you using, computers now?
Yeah, and so you're just going to have a much slower rate of change over there because they are not able to adapt as quickly.
Yeah. Good question, Noah.
Absolutely. And with that, we can start wrapping up this episode. I had so much fun learning about monotremes. I hope you all enjoyed. If you have favorite facts or monotremes or any, just if you have questions, please let us know. We would love to talk about monotremes with you. You can find all those links down in the description for how to get in contact with us.
As with all of our stuff, there's a bonus stuff on Patreon after we do episodes. We do director's notes, and we also have bonus news and additional thoughts on things that we put up on Patreon. Also, it's the end of May, which means that, as a reminder, Croc and Snake Month are around the corner.
Yes, indeed.
June is Croc Month. July is Snake Month. As we mentioned at the top, we will have special stuff going on our Discord, on our social media. We'll have bonus episodes, and we will have special limited time Patreon tiers where people can get limited time rewards, but also contribute to donations we'll be making to conservation and research efforts for crocs and snakes. We are very excited to get in to Croc and Snake Month for the year.
So get geared up for that and keep your ears out. And without further ado, we release episodes every fortnight.
We sure do. I think technically this was like 2 hours of ado.
Yeah.
There's a lot of ado.
Yeah.
But no more ado.
Without further ado.
Without any more ado.
With a lot of ado and now no more of it.
Thanks for sticking through the ado. Every fortnight.
Bye.
See ya.
Thanks for listening to the Common Descent Podcast. You can follow us on Facebook, Twitter, YouTube, and check our WordPress blog for pictures and links after each episode. Huge thanks to our patrons whose support helps keep this podcast running and who get access to bonus goodies on Patreon. The song you're hearing is called On the Origin of Species by Protodome, which we found at ocremix.org. Thanks again for listening. We hope you'll join us next time.